Hello everyone and welcome back to the Architect SuperMod build part 6. There's a lot of cool stuff happening in this week's episode, such as skis, brake, engine porting, and a lot more. So without further ado, let's get right into it. The first thing we're going to tackle this week is the front skis. I could have gone the easy route with using the same skis I used for the G4 and the Alpha and just scale it accordingly to the snowmobile. However, I feel like this specific snowmobile has got something special and I want to go all out with it. So I decided to design a brand new set of skis based off of the Polaris RMK of modern years. The amount of details in these is quite simply stunning. I spent a ton of time making them. The size of the machine is about 23% of a real sled, so halfway between a 5th scale and a 1/4 scale. We will talk about that a bit more in the next episode. To give the skis a bit more flotation, I went with overall 5% bigger than the exact scale and another 10% extra on the width. They could have worked the way they are, just printed like this. But because I want this to be the best sled I can, and because we're gonna run a studded track, I decided I was gonna add a stainless steel keel runners to them. These are essentially square machine key stock, and once they were bent into shape, they are going to do the perfect job at keeping the snowmobile on the right path. I then drilled a couple of holes in it and installed M2 screws. I then welded them on the keel to make it all one part. Once the head of the screw was grinded away, we are left with these beautiful scale looking carbide runners. I know they're not actually carbide, but we all know what I mean by using that word. The beauty of the design is that it actually installs just like the real thing, using a few nuts on the top. I use some thread lockers to make sure they don't back out. Since this is a new design, I wanted to make sort of a ski rubber to angle the ski properly, so it does not flap around when the skis are off the snow. As it's made of TPU, it does flex a bit, so if you hit something, the skis will still have a bit of motion. The ski hoops are then added with 3 M3 screws. As you guys voted for yellow and red in the previous poll, that's the color we're going with. I thought we were done in the front suspension, but as it turns out, the plastic square piece that holds the 4 radius rods in place snapped during the assembly. And after taking it off, I realized just how bad that part was. The plastic was so brittle that I could snap the corners with just a bit of force. I knew this part was weak, so that's why I added a thin carbon fiber piece to help it, but as the part was just crumbling in my hand, I realized that it was simply not enough. Back to the drawing board. I cut 2 squares of 2.5mm carbon fiber plate and glued them on the part to use as a template. I then drilled a couple of holes through it for the future screws. And then made a small plastic piece to go in the middle that would hold the carbon pieces together. 2 more holes were drilled and we can add M3 button head screws to it to hold everything tight. I purposefully made the plastic part a little bit bigger so that we can trim it flat once the carbon pieces were assembled. A test fit revealed that the button head screws were a bit too tall, so I grinded their heads flatter, so now it's fitting a lot better. We can now install the radius rods in place and put the main bolt through the frame to hold everything. And just like that, the skis are installed and everything looks the way it should. Next up, let's tackle the most complex and difficult part in the entire snowmobile, the braking system. The last time I've built a Architect snowmobile, I used a leather strap against the clutch belt to slow down the snowmobile. But I want a more elegant solution this time. I want a disc brake system, like the real thing. The first option I considered was the Traxxas disc brake and pads you can find on the Traxxas Revo transmission, the same ones I have on this custom buggy that I'm slowly building. It does use a vented disc and 2 aluminum brake calipers bonded to fibrous material. It would have been perfect to use in our case if it was just a little bit bigger in diameter. The rotor is 40mm, which is way too small. the Architect pulley is 60mm, so it would have been buried down in there and difficult to make it work. The next option was an aftermarket front brake system for the 1/5 scale HPI Baja 5B, but everything was just way too big and it would have had to spin through the frame right in the snow. That's not gonna happen. The third and final option only happened because of a new product on the market, the Losi MX Pro Moto. Because this vehicle exists, we can get aftermarket parts like this hot racing aluminum rear brake disc. It's 6061 and you can get it for a very good price. I want to give a very special thank to my friend Gregory for pointing me in this direction and going above and beyond to make this possible, including shipping the parts to me for free so we can get this sled ready as quickly as possible. Thanks, man. Everything about this is basically perfect. It is light, thin, and just the perfect size. All we need is to find a way to attach it to the main pulley. Unfortunately, it does not have a good surface to mount it to. So I went online and found a 36 tooth XL pulley that will do the trick. We need to do some work to it before we can install it though. So I got an 8mm drill bit and used it to support the pulley on the lathe. I started by doing a recessed area so that I can find the center of the pulley. Here's a little test fit to see if every hole lines up. So far so good. I needed to get as much clearance as I could between the motor and the face of the pulley. So I removed the ring that holds the belt in place and reduced the thickness of the pulley itself. I can then glue back the ring into a new position. After all this work, we have a connected brake rotor to the pulley. But now begins the real challenge. The brake that comes with the MX Moto is way too big to be used in this application. There is no way it would fit even with some modifications. So I fired up the computer and took a few measurements so that I can hopefully use the brake pads but completely remake the caliper. The first version was pretty crude, but it was just to verify the clearance around the pads. The next few versions were a bit more in the shape I wanted, but what good is a caliper if it's just there for looks? I decided the best way to activate the pads would be with a rotating cam. So I took a Dubro color and used some sandpaper to round out about half of it. I then added features to hold that part in place, and with a few trials and error, I ended up with this functioning brake caliper. It works shockingly good. When the cam spins, it pushes against a metal nut that applies an even pressure on the pad. It also prevents the cam from damaging the back of the pads and digging a hole. Overall, I'm very happy with this design. You can see how everything is crammed in here. The grub screw is less than 1mm from touching the pulley. That's tight. In order to install everything, we need to split the frame in half once again. The first step here is to install bearings and drivers into place. I had to trim a bit of plastic to make the pulley fit. I then added a small shim and a C-clip to hold the shaft into place. We can now install the pulley and the caliper roughly where it needs to go. I drilled 2 holes through the frame and used 2 M3 button head screws with their heads grinded down a bit to hold the caliper in place. In this moment, I realized I didn't hold into account the draft angle of the molding of the frame, so I had to modify the caliper a little bit for it to sit flush with the rotor. I also tested the rotor to make sure it was flat and didn't have a stiff spot when spinning. I think this is good enough. With everything installed permanently, I can finally test it in the real world and see if it works. And I was pretty happy to see that it was working better than expected. Now to activate the brake rotor, we need some sort of a lever that would grip the shaft. I used an old RC gear. and drilled a hole in it for a pushrod to go through. I then used a very weird and mysterious tool to make the pushrod. It's a Great Plains Z-bend pliers. Making pushrod is a lot easier with this instead of manually doing them. In one of my venturesome adventures on the web, I stumbled upon these silicone Kevlar high temperature XL belts. They are extremely flexible, yet do not stretch because of the Kevlar. They literally feel like a thick rubber band. I am convinced that using these belts will free up some horsepower, as the belt is easier to maneuver around a small pulley. The added high temperature resistance is a nice added bonus. Time will tell me how to handle the abuse. Another modification I've been wanting to do for some time is install a different clutch end washer. The problem is the washer spins with the flywheel of the engine, so it could damage one of the side of the belt. To solve the issue, Art Attack offers something called the Cullis clutch. But since I do have a lathe and I don't want to wait for the new part, I decided to make my own. It's not perfect, but it will do a lot better than the original. Next up, we need to remove all the bolts that hold the engine in place and add some thread locker so that they don't loosen over time. And while I had the engine off, I decided it would be the best moment to tackle something I have never done before: engine porting. Oh boy, here we go again. I have seen a few videos and online blogs that discuss the process, but never decided to do it. What better time to do it than on a sleeve of an engine that is no longer being produced? Yay! I will do the strict minimum. I will not be doing crankshaft porting, for example, but I will do all the commonly done things on the sleeve. When doing nitro engine porting, there are 3 things to keep in mind. Don't go inside the sleeve, don't touch the exhaust port, and keep the mixture swirling as it goes through the transfer and the boost port right into the main combustion chamber. After some small work with the Dremel and a diamond bit, this is the result. I might have gone a little aggressive on some of them, which usually increases the fuel consumption, but that's not really an issue in my case. I'm not on a racetrack, so I'm willing to take the risk. I then use a polishing wheel and some compound to polish the port a bit. Overall, I'm pretty happy with my first experience. Slow and steady definitely is the way to go. I also had to replace the silicone seal on the muffler as it was cracked and not sealing well at all. With the engine installed in the sled again, it's now time to install the muffler in its final spot. It's funny that even at this scale, you still have to deal with muffler springs. I think I did a pretty good job installing that muffler. We've done a lot of complex work this week, so I'm pretty happy with how everything turned out. I also decided to check again the balance, and it seems that without the battery installed, the weight balance is nearly perfect. So I think we will just have to relocate the battery to somewhere else, which is not a problem. We have plenty of space under the seat. With the skis installed, the pulley, the belt, the brakes, and the pipe finally in place, it's really starting to look like a sled. Since the track is ready, I think next week we should work on the skid, the fuel tank, and the electronics. Then we will have a rolling chassis and we can finally do a first fire up. What do you think of the snowmobile so far? Would you have done something differently? Please let me know down in the comment section. Thanks for watching and thanks for riding with me.